So, I'm Lizzie. I'm a developer evangelist at Kubeflow, and I am beyond excited to introduce our next speaker, Holden Karau.
Awesome. Thank you for having me. Normally, I take a picture of the audience to send to my boss to convince him that it's worth my travel time, but I didn't have to travel today, so I'm very excited to be here. And it looks like you're all listening to someone other than me, so I'm not going to take the picture. The headsets give the wrong impression. Can people hear me okay? This is weird because I don't hear myself at all, but that's okay. There are slides, and if you are the kind of person who likes to look at slides after, this is a bit.ly link where you can find the slides, and I'm also going to reference some code labs, and I'll link to those code labs from that same URL as well. And I'll do that after this presentation is done because, like all good presentations, I was changing my slides 3 minutes before we got started. That's where they're all going to live. I'm Holden. My preferred pronouns are she or her, and I'm a developer advocate at Google. I'm on the Spark PMC. Are there any people here who happen to be Spark users? Yay! Thank you, 4 people, for justifying my existence in the world. And previously, I worked at a whole bunch of other companies. They were all nice. They paid me money. Nice folk. I'm a co-author of 2 books. If they're both about Spark. You can use Spark for machine learning. We'll talk about why that's bad momentarily and why the examples are not in Spark. If you want to follow me on Twitter, it's just my full name. Slides are also on SlideShare if you didn't take a picture of the last one. And one of the things that I've started doing that I'm excited about is live code reviews. And this is for people who are interested in seeing how large-scale open source projects do code reviews, because it may be different than how you do them internally to your company. I live stream those about once a week on Friday mornings. And I think it's kind of fun, and I hope to trick more people into reviewing open source code with me. So far, mixed success. In addition to who I am professionally, I'm trans, queer, Canadian, and part of the leather community. I'm here on a work visa, and it's a very exciting time to be in America on an H-1B work visa. I won't ask you to raise your hands if you're on a work visa. It's maybe not the greatest time. But I think for all of us who are looking to build machine learning tools or building machine learning models, we should look at our teams. And if when we look at our teams, we see only people like ourselves, perhaps this is a sign that the tools and models we're going to build are maybe not going to be as representative as they could be if we had more diverse thoughts and inputs. And I think it's really important for us to have diverse teams building machine learning models. Otherwise, we'll just burn the world down faster with data. And certainly, I can make money doing that, but I will destroy what is left of my soul. So let's not do that. So I'm hoping you're all nice people. I'm assuming you're here because you're interested in machine learning. If you're not, this is maybe not a very exciting talk. If you're really excited about shell scripts, I do have some shell scripts in here though too, so don't worry with multiple audiences. Okay. That is, I don't know if you can hear that, but they are introducing the other session at the same time. And so that's fun. I'm actually really curious. How many people here are Java programmers? That's a good representation. My next guess is Python. Okay. And Scala. Okay, it's the same 4 people that I saw for Spark, so not overly surprised. Who works in a language that I didn't talk about? Okay, that's a good number of people. Does anyone who raised their hand want to share what language they work in mostly? Okay, see, that's used a lot. Wasn't expecting it at the machine learning talk, but that's cool. Anyone else? Okay, C#. Any languages, any other ones that I was missing? R programming. Okay, cool. Well, there's certainly some R integrations into Kubeflow. I don't talk about them, but they do exist. The C integration's not really at the user level, but you can definitely build components in C. You don't see as much of it being built in C. And C#, I have not actually looked for any of those examples, but maybe we have them, and I just am not up to date. Okay, so this is going to be, we have a lot of ground to cover and about 30 minutes. So a lot of these things are going to be a little brief, with links for you to go deeper into the parts you care about, but hopefully they'll be deep enough that you'll still find them interesting. We will finish up with the scary thoughts of updating models and validating, and we'll save all of the things that could really destroy your company for the last slide, because that way we can end on a really sad note. And I find that's really great for making people feel good about coming to these talks. So how many people are familiar with Kubernetes? Okay. How many people are not familiar with Kubernetes? And everyone else is asleep. Okay, cool. So for those of you who aren't familiar with Kubernetes, you can picture magic plus containers, and that is about the level of information that is required. You can just think of it, it's a cool tool, I run it. Someone else might run it for me if I pay them money, but I will have to pay them a non-insubstantial amount of money. And in exchange, I can schedule my jobs on a cluster, and everything just works except for when it doesn't, and then you buy a support contract. Okay, so for those of you who don't know Spark, it is not overly related to this talk. I was hoping to have more of it integrated into Kubeflow, but you can look at this PR that I have. It's PR number 1467 in the Kubeflow repo, and it has a work in progress Spark implementation for Kubeflow. It's not finished yet. You could use it if you were very adventurous. I have a collection of shell scripts that demonstrate that it kind of works. And it does have ML libraries. And one of the challenges that we've seen with Spark is that we built these cool machine learning libraries. And a lot of other systems did this back when Spark was being created. And we built those libraries. We made it really easy to train models. But then we didn't think through how people would use the models. We were like, well, no, you trained your model, you're done. But it turns out that most of our businesses aren't interested in just like having a model to keep on the shelf. They're not like, I have this wonderful artisanal model, it was handcrafted with years of data science experience. They want to apply their models. And Kubeflow is very much about allowing us to go all the way from training to serving without having to learn a whole bunch of different systems. And so Spark has a whole bunch of different pieces in it. I just referenced the ML ones, but in case you think that Spark is just a bad machine learning tool, it is bad at many other things as well. But don't worry, everything is bad, and it's just a matter of trade-offs. And so it can also do graph processing and other things like this. So let's go and focus more on ML. What does traditional ML look like? First off, we write some code on our laptop. You know that you can do this in your kitchen, like this cat is doing. I believe that the natural habitat for a data scientist is in a coffee shop in San Francisco, from what I've seen from Twitter posts. The coffee can't cost less than $5, and it's no longer science; it's engineering. And you write some code, and you're like, hey, this works. I built a model, and it looks cool. I tested this on literally kilobytes of data, and that's all I needed. It was kilobytes. That's fine. Okay, so you trained it on kilobytes, but then someone comes to you and is like, hey, we have more than 5 customers, and I was wondering if your model might benefit from using the data about all of our customers. And so then this comes to the point you're like, well, I should probably use a big computer which has a cat hidden inside of it rather than the cat on the outside. The cooling properties are a lot better. And so you deploy to the cloud, or you buy a rack of computers, and you train on a fancy ML rig with GPUs or TPUs or whatever you want. And then you've got your model, and you're just going to put it into production. And there we go. Yeah, and technically that is in production. And that's often how many first ML model deployments go. And conveniently, unlike the people who presumably learned from doing this with their ship, we tend not to learn for our second deployment. We're like, we got all of the bugs out from the first one. We'll just do the same technique again, but it's going to work this time, right? And then we do that, and we're surprised that it doesn't work. Okay, so the problem is, the first part was fun and exciting, right? Where we were like hacking away on our laptop. That was cool. We can be like, yeah, I'm a machine learning engineer. You should pay me money. And in exchange, I will take your MacBook from you. But it turns out that feature prep is hard. So once we actually need to start using non-clean data. And this is the problem once you go beyond Kaggle competitions or mnist.csv. It turns out that almost everyone has unclean data. And that's can vary from like just straight up garbage information in some of your records to just data which isn't in the right shape to use for machine learning, right? Like some algorithms don't really handle binary, pictures very well, and other algorithms do a much better job with binary information. And if you're trying to use these models on the wrong types of information, you have to re-encode it into the ways which are usable. Training is tedious. So yeah, when we ran it on our laptop, that was great. But now someone wants the model every week, or heavens to bid, every day. And we probably don't want our job to become the person who comes in and presses run on an IPython notebook. That is a very easy job, but one which may be replaced by a computer. And I prefer my job to be difficult to replace and also less tedious. And once we trained our model, no one really thought through how to use it. And this is really obvious with systems like Spark, where we literally did not build a serving layer for years. And we were just like, what? Just build it yourself. It's not that hard. And now we finally started to build one, and we realized it was really hard. But hindsight. So what is Kubeflow? Many people might think that Kubeflow, from its name, it could imply that it's Kubernetes, which is this magic-liking person, containers, and TensorFlow. How many people thought that's what Kubeflow is when you came to this talk? Okay, not too many. But for those of you who raised your hand, I'm sorry to disappoint. That is not what Kubeflow is. Or not entirely what Kubeflow is. Kubeflow is a wonderful collection of tools which can include TensorFlow. You can have wonderful Jupyter notebooks. Your model training has a large variety of tools, and even your model serving has a variety of tools. You can use things from Flask to TF serving to Selden Core. That being said, the TensorFlow integration is clearly well done, and we'll look at how that works, because that's normally why a lot of people are interested in Kubeflow. So Kubeflow is a cloud-native platform for machine learning based on Google's internal machine learning pipelines. And that is the direct quote from the project website. And it's the recognition that we need to do more than just the fun part. We have to do feature prep, and we have to do serving to really be at all useful. And it's also open source. I want to be clear. I'm not like trying to sell you something for money. The stuff is open. You can use it. You're, of course, more than welcome to give my employer money. They are very excited to receive it in the form of cloud hours. But you don't have to run this on Google Cloud. You can run this on Azure Cloud just as easily, and even your in-house cloud if you have Kubernetes. So at the end of the day, Kubeflow exists to replace the entire mess of things that we did to get our machine learning models from that laptop into production. And that's what we're going to talk about. So let's say that we actually want to use this, right? We have this giant mess that we want to replace, or we haven't trained any models yet, and we're going to start training some models soon. What are we going to do? So the first one is to step away from the keyboard, right? It can be really exciting to go find a step-by-step guide and just replace the data, right? Be like, I'm just going to take this guide that someone else did, and I'm going to swap in my own data set, and this is going to be great. And the answer is it's probably not going to be great. You should sit and think about what it is you're trying to do, right? There are a whole bunch of different models you can use. If you have 5 megabytes of data, deep learning is probably not the tool you want to use. That is going to go really badly. You probably want to use something like linear regression or k-nearest neighbors or something like that. So don't just jump in and run. Sit back and think. And then Kubeflow, it's not just TensorFlow. So if you decide that you're not using TensorFlow, that's OK. You can still use Kubeflow. Go and look at the components and see which one might match. Relatedly, let's go and look at some of those components. So not all of these are what we would traditionally think of as machine learning jobs. Argo, for example, we can get data around. Chainer job just change things together. MPI is not what one thinks of as a classic machine learning tool, but if you're building really custom things in-house, you might want to have some MPI jobs that you're deploying. And you'll note that there is, of course, TensorFlow, there's PyTorch, and MXNet, and other things. I'm trying to get Spark added here. If you want to help me, there's that PR, and you can come join me, but it's not yet in this directory. And this is not a extensive directory. This is the the list that would fit on a slide. So what about if that's fine and all, but you just really want to get started. You want to deploy Kubeflow into production. Someone told you that you have to do machine learning in Q3, and it is starting to get a little close. So that's okay. It's pretty easy, assuming that you have a Kubernetes cluster. And since I work for Google, we'll assume that you're deploying to the GCP platform, but you can replace that platform with many other fine vendors. You apply this to your Kubernetes cluster, and you have fun. Yay! Okay, now I have Kubeflow. We're done. Okay, no, just kidding. So once we've deployed the core components, you probably want to pick which machine learning tools you want to use. And while I said we could use things other than TensorFlow, let's just use TensorFlow. It's nice, it's fun, and if we tell our boss that we trained a TensorFlow model, that sounds a lot cooler than I trained a logistic regression model, right? Your boss is like, I've seen logistic regression in Excel. I paid for data science. I expect something fancy. And so you're like, no, I use TensorFlow, very fancy. Okay, so thank you for laughing. Sorry to single, okay. Okay. So the other person is very excited about tacos for lunch today, and this is distracting me. Okay, so that's cool. Maybe you want to use Jupyter Notebooks. Okay, so we can set up port forwarding, so we can go in and we can start accessing, the UI, and the UI gives us notebooks, and we can interact with this interactively, rather than just pressing a bunch of buttons in our terminal and hoping that it works, right? I can have an interactive notebook where I can go back and look at all of the times I failed, or succeeded if we're lucky. And now we get to do some special ML training, right? And we can do this in the notebook, right? We can submit a random job against it. And there are so many different algorithms we could choose, right? We could use TensorFlow, which is maybe not surprisingly, it's the job we deployed, so it's where we're going to go. And we can, of course, look at the Hello World example. And it turns out I've got 12 minutes left, so we're going to do MNIST, because I can get through MNIST really fast. Okay, so Keras and MNIST and happy things. Okay, so more or less, you're just going to end up copying and pasting something from a notebook and plugging it in here. And the nice thing is, you're going to, this is only part of it, but this is where we do our fun fitting, and we have a validation split for training. And if you don't know how to train a machine learning model, unfortunately, I can't teach you in 12 minutes the entirety of TensorFlow. I'm very sorry. But that's okay, right? You can go and you can look at these examples and you can try and adapt them, which is what I told you not to do, but you can do that as a starting point. Just don't put that into production. And that's fine. But you may work at what's called a real company with what we tend to call special business logic. That's a polite way of saying Fortran code or COBOL code, which no one remembers what it does, but it's the only way to get at our data. How many people have to interact with something that was originally written perhaps before they started their career in programming? Okay, that's just me and one sad person in the back. Okay, so for the rest of you, you're very fortunate. Maybe I've just worked at way too many legacy companies. But you may still, even if you don't have legacy data that you need to interact with, you may have a special yak shaving tool that your company requires you to use or you want to use, right? You may want to use Spacey for tokenization or something which isn't built into the default. And it turns out that it's pretty easy. We can say, like, this is what we're going to be based on top of. These are the additional things that we want installed. And then we do a Docker build, and we tell Kubeflow that we're going to use our new special image, and our new special image is going to have whatever extra tools we needed to do our special business logic. And now we get back sort of to the other part where we want to do feature prep, right? We maybe started going through one of the examples, but then it turned out that all of the examples kind of leave out feature prep because they have clean data, because they did their feature prep before and saved it to a CSV file and pretended that they didn't have feature prep. And so that's great. But there's some really cool tools that we can use, and conveniently, they are integrated into Kubeflow. And TF transform is one of them. It's for pre-processing your data. It has a focus on TensorFlow. It outputs graphs which can be served from TensorFlow, which is very convenient. And it handles big data, which is also convenient because if you don't have big data, you probably shouldn't be using TensorFlow. That's my personal opinion. And so this is good. It has some interesting challenges if you want to use it on a pure open source version right now that they're actively being worked on. There's some fixes in the master branch. Once again, I tend to get excited as soon as code is written. I don't wait for it to get released. So if you want to go and do this, you're going to have to check out the master branch of that project. But you can run it, and it's exciting. And we can write things relatively simply. And what this says is like, hey, we want to center this variable, the other variable, we want to scale it up between some range. And someone gave us some string data, and it turns out that these strings are actually just labels, so we're going to create a mapping from these to some integers. And there's a whole bunch of other things that are available. If you've written Spark code, the fact that this is so simple to write may make you happy. So for those 4 of you in the room, you may be impressed by this. For the rest of you in the room, you may think that this is like really basic, and you could do this on your own. And it is true, you could do this on your own, but doing this on your own in a distributed system is painful as hell. So using someone else's distributed system is easier. And so this, creates a bunch of analyzers. We apply some data to these analyzers, and it outputs constant tensors, which we can then use in our TensorFlow serving graph. And then we can have our feature prep stages properly represented as part of a single model serving thing, rather than having a separate feature prep stage, which we now have to figure out how to shoehorn on top of our model serving. And here's a bunch of different sort of common use cases for feature prep that you can do with TF transform. And here's all of the caveats. We'll skip those because they make me sad. But you can go back and read them if you're seriously considering doing this. Okay, so let's say we did some feature prep. We followed the example from Michelle on how to train MNIST or some GitHub summarization data, and we switched it into a cat finder 3000. And so now we're going to go ahead and we're going to generate some serving layer code. And there's, it's cutting off the bottom of it. Oh well, there's a whole bunch of different options that we have for doing serving. But TF serving is pretty simple. So we'll look at TF serving because it fits on one slide. One slide makes me happy, right? I can get a little serving thing, and I can now start querying this with REST. And this is really a lot easier than our other options. Another option, which if we didn't use TensorFlow, right, if we used sklearn, if we trained a model in R, or if we used H2O, or even SparkML, even though it's only sort of supported, it gets a little bit more complicated on how we would get this to work. This is how we set up the serving code, or this is how we set up the serving service that we will use to create a service to serve. I think I got the number of services in that statement right. I might have been missing one. Then we build an image with our model inside of it. This is a little frustrating because we're baking our models into images, and that means updating is a little bit more challenging than with the TensorFlow one, where I could just change my configuration parameters. But that's okay. We point it to our happy model. We build it. This one's the issue summarization one, and we say that it's Python 3.6 because Python 2 is finally going away. Thank God. And then we finally kick off our serving layer, and we tell it, hey, I think we're going to need 2 copies of my serving layer. That's about as many sort of requests that I'm expecting to handle. And we just configure that number statically, and we hope the world never changes. Okay, so how do we use it? For either of these, they both expose a REST interface, and now you use your favorite REST library to query it. Timeouts kind of matter, and this is important. Depending on what you do, right, you want to handle your failure to predict a result differently, right? If you're deciding something about, what medical action to take on a human, you probably don't just want a default value of like, tickle their feet. That's probably not going to lead to the medical outcomes you want. You probably want to explicitly throw an error message, say something went wrong, go get someone qualified to help me. Alternatively, if you're selling ads to people, maybe if you make, your predictions aren't succeeding in time, it's a great time to try and sell them Furbies. Everyone loves Furbies, and I have a warehouse full of them. So, that can be okay, right? And I've written prediction systems where, and we didn't actually, our fallback wasn't Furbies, but our fallback was just the list of the most popular categories, right? It's like, hey, something went wrong with my machine learning job. Would you be interested in some toast? Right? It's a perfectly fine option to just return non-personalized results some of the time, and that can be very useful. If you have different models, you can fall back to your other models. If you're doing this in batch processing, maybe you're doing a fraud job in the evening, you could skip all of the steps that we just showed you about setting up a microservice for training, and you probably just want to integrate your model into your batch job, right? There's no reason to query this over a REST interface. I should just bake my model into my batch job. Okay, scaling, replace the number 1. Actually, this should have been a replicas 2. So you replace the number of replicas from 2 to 10, and you keep increasing this by an order of magnitude until your pager stops going off, or accounting starts calling you. And then you just go back and forth until you find that sweet spot, and that's what we call hyperparameter tuning for a number of replicas. Bad joke. Anyways, so is this really what we do for scaling? So if you were doing this on your laptop, the first type of scaling that you do is switch from your laptop to a cloud. And the other one is then you switch to horizontal scaling. Auto scaling is a work in progress. If you're excited about contributing to open source, you can come and join us on this issue and help us make this not a thing which you do randomly by tuning knobs. You can help us make this really cool. Okay, I've got 2 minutes left, so we're going to skip all of the things which could potentially destroy your company. Validation's important. You should do it. There's some links, and there's no time for a demo, but I have a fine collection of recorded demos that I promise you were not edited. And if you watch them, you will believe they were not edited, based on just the number of times that I swear, and the one time when I forget where I stored my model. And so you can come watch these recordings. You can go and do these in the code labs. You can do them online by yourself, self-paced, or one of them's at the Google Cloud booth if you want to come join us there. Relatedly, I will be there right after this talk is done. And my coworker, Casey, is giving another talk about building Captain Obvious at 6 p.m. So thank you all for joining me. Oh, yeah, there's some other shit, but we'll skip it. So thank you. Feedback is welcome, but I'm out of time.
Okay, do you have any questions? We have about 1 minute.
If you could pretend to be excited for a second, I still will take a picture, just in case my boss questions my subway expense report. It was $6. Oh, thank you for waving. That really helps. That sells it. Oh, this side of the room doesn't have as many people, so if you could be more engaged. Yes, thank you. Thank you. The dance helped.
Any questions? I can run around.
You can also just come find me at the Google booth so the next speaker has time to get set up.
Okay, so no questions. Thank you all for coming. Thank you, Holden. Okay, and okay, we can clap.